Hi, in this tutorial I want to show you the basics of injecting code into a game. We're going to change Dishonored so that your magic doesn't go down when you use it. In the last video we found this piece of code here that sets your new magic value when you use it or when you have a potion. So let's copy this address and go to our memory viewer and go to that address, and there's our code. So first we go to Tools and Autoassemble. It opens up the Autoassembler window and use a template for code injection. It's the right address and it will create this for us. This is basically what you need to inject the code into the game to call your own new code. Let's assign that to the current cheat table. Oh, we need an enable section. So cheat table scripts need two sections. Enable will get assembled, that's not executed but assembled into memory when you check the box. And the disable section will get assembled into memory when you uncheck the box. So all this code here, let's look at what it does. It allocates a new section of memory, 2K in length. Actually, the minimum is 4K, so we'll go ahead and put that there. 2K works fine, but it ends up allocating 4K anyway, so why not use it? We create a few labels. Now this just reserves this name. It'll be set later, and you can use that in your code before it's set then. Since the alloc allocated this memory, it assigned its own label called newmem. So what this does is it tells the assembler to start assembling code at this address, which is our newly allocated memory. Creates a label called original code. This sets the value of the label to the current position in the assembler, which is newmem also. And then assembles this instruction into that memory. Creates a new label called exit that we can use later that points to after this instruction, and it creates a jump to return here, which is set later. This changes the current pointer in cheat engine to start assembling new instructions at this address, which is in the game memory. And those 6 bytes are replaced with a jump to our code, which takes 5 bytes, and to fill it out we have a no operation, which does nothing. Then it sets the value for the return here label to where the next instruction is, which will be that ACB. So in our disable section, what we want to do is put this code back where it is. So let's just copy it. So now when we uncheck this cheat in the table, it will start assembling at this address and put this code there, which is the same code that's there originally. Now let's assign that to our current cheat table. Call it unlimited magic. Let's get rid of these values that we don't use. Now if we try this in the game, it won't actually do anything, because all it's doing is jumping to our new memory, executing the same thing that was there before, and jumping back. Let's just comment out the instruction that sets our magic to the new value. Oh, got to do that in the save script. So now if we go to the game, or that, checking that, assemble that jump instruction, and if we follow that, this is our new memory. It was allocated at B2D whatever, and it just jumps back to the following instruction. Which does that compare? So if we go to the game, this is our magic. just hop right around and our magic never goes down. So let's uncheck that to put the original code back. And anytime I write a cheat script, I like to copy and put in the comments a lot of the surrounding code. That makes it easy to find in the future. Let's copy a bunch of bytes on either side. Put that in a comment, which you can start with a curly brace at the bottom. And mark up what we're doing here. That A60 is the last magic value. And that A5C, that was the maximum magic value. Okay. Now, something I think you should always do, well, if the game is updated, these addresses will be different for the same code. And if you don't take care, just checking this, if the address is wrong, will screw up some code in the game and almost certainly make the game crash. To prevent that, we can use the assert statement. What the assert statement does is make sure that this address in memory contains certain values in bytes. Let's copy them down here. So this is an array of bytes, and if this assert statement fails, it means these bytes aren't at this address. It will not execute the rest of your script. You see that it still works. But if we're looking for different bytes, trying to check it just does nothing. You should also, in your disable section, probably free up the memory that you allocated. No longer being used. It's not that important when you're only allocating 4K at a time, but it adds up.